Okay, so shh. You guys ready? All right, so we are starting our unit on rational expressions today. So the first thing we look at is how to simplify rational expressions, and we want to do it without killing puppies. Those are the most common type of animal to die based on the wall, and so we're going to make sure we don't kill any puppies, okay? It is when you cancel on a fraction, a top and a bottom, that you're not allowed to cancel. Yeah. So today is the day that we first learn about it, and then our goal for the rest of the unit is to kill as few puppies as we can, okay? Because it happens all the time. No. All right, so here are the steps that we do for simplifying a problem. First, we have to make sure the problem is written as a fraction, that it has something on top, something on bottom. Often they will give you the problem written that way already, but sometimes they write the problems like this, and then you have to write it as a fraction, okay? Then we want to make sure that each of the terms are in the correct order. So if it's written like out of order like this, we would just want to make sure that we have our exponents in the proper order, and you guys are pretty used to that at this point. After that, we factor the top and we factor the bottom. So factoring out a GCF, difference of squares, the diamond method, you could put slash slide divide. You might use the slide divide method too. The one thing that students often forget to do is factor out a -1 if the first term is negative. So I would say underline that, put a star next to it, highlight it if you have a highlighter, but that is something that students forget a lot. So if the first term is negative, then you're going to factor a -1 out of the entire numerator or the entire denominator. The next step is to cancel out things that divide to make 1. So if you have a factor on the top that's exactly the same as a factor on the bottom, then you're going to cancel those to make 1. If the entire numerator or the entire denominator gets reduced, then you leave a 1 in its place, not a 0. You leave a 1, okay? Because when things divide, they divide to make 1. They don't divide to make 0, okay? So at the very end, you should have something written as a fraction most of the time. It could be a whole number at the end, but it's often a fraction, and it should be completely simplified, okay? So if we look at example number 1, we would call this a monomial because it has one piece, one term on the top, one term on the bottom. So all we have to do is we have to think about what number we could divide out of 18 and also divide out of 24. 6. So 18 divided by 6 is 3, 24 divided by 6 is 4, so we can do that. And then if we think about the x to the third and the x squared, we can reduce that as well. Yeah, so x squared can come out of the bottom, x squared can come out of the top, and it will just leave one x in its place. And so that leaves us, yeah, 3x, not 34, 3x. 3x on the top, 4 on the bottom.
Wait, why did we cross out just 3?
So it was kind of like we divided by 6 on the top and divided by 6 on the bottom. So 18 divided by 6, 24 divided by 6. So we were reducing the fraction. All right, if we look at the next one, this one kind of like they did step 1, 2, and 3 for us, and then we are starting on step 4. So if you look at this, the only thing that you can cancel is x divided by x makes a 1. I cannot cancel these x's over here because that would kill a puppy. Okay? The reason it would kill a puppy to divide these two x's is because this isn't x times something, it's x minus something. And the bottom is x minus something, so if you tried to cancel them, you'd be trying to tell me that minus and division cancel, and they don't. Minus and division never cancel, okay? The reason that the other x's did cancel is because it was 7 times x times factor, 3 times x times the factor, and times and divide do cancel. Those are opposites, okay? So here we would say that our final answer is 7 times x minus 1 over 3 times x minus 2. Or if you want, you can say 7x minus 7 and 3x minus 6. Those are both good answers. On a test, those would both get full credit. I don't prefer one to the other. Or if you want to leave the top factored and distribute on the bottom, that's fine. You can go crazy with it. The choice is yours.
Well, you usually halfway done at the top, and you decide not to do the
That's not okay, though. You could go full one way or the other.
No.
All right. So for the next problem, they didn't start any of it for us, so we have to do it from the very beginning. So what is the first step?
Put it like.
Yeah. Write it like a fraction, right? So the top is x squared plus 9x plus 20. The bottom, x squared plus 13x plus 40. And I can already look at that and say, oh, that's 1/2, right? No, that would kill a puppy. Don't do that. That's so sad. You can't go straight from step 1 to step 4. That's weird. Okay, so step 1 is done. Is step 2 done? Are they in descending order? Yes. Okay, so step 2 is done. They put them in descending order for us, so that was nice. What is step 3? Factor. Okay, so for the top, we are looking for two things that multiply to 20, but add to 9. I cut it when I was washing dishes on a knife. I cut it on a knife.
4 and 5.
4 and 5. So x plus 4, x plus 5. Okay, and then for the bottom, we're looking for two things that multiply to be 40, but add to be 13. 5 and 8, so we have x plus 5, x plus 8. Now you can reduce factors that are the same. So x plus 5 divided by x plus 5 reduces to make a 1, right? The same thing over itself is 1. And so that leaves us with x plus 4 over x plus 8. And we should just go and cancel those x's and say 4 over 8 is 1/2, and we're done, right? No, 2 puppies would have died if I did that. Oh my goodness, don't kill. All right, so our final answer is x plus 4, x plus 8. We cannot reduce these any further because it's an addition problem on the top and an addition problem on the bottom, and addition and division do not cancel out. And so that means we are done.
Oh, yeah. So it's multiplying.
It's multiplying by 1, so it doesn't, yeah.
But I want it to be a nice answer.
Yeah, that is a nice answer. That looks nice. You should see what they can do sometimes. They can look crazy. All right, let's do example number 4. So before we do anything else, what's the very first thing we do? Write it like a fraction. Okay, so I'm going to go ahead and say negative 6x plus x to the third divided by x squared plus x. Okay, what is step 2?
Switch the top.
Yeah, switch the order so it's correct. X to the third minus 6x over x squared plus x. Step 3 is to factor it. So when I look at the top, what do you guys see on the top? Take out an x. Then I get x squared minus 6. What do I do on the bottom? Take out an x, and then I get... Okay. Are we done with step 3? Can we factor anymore? No? Okay. Step 4. Cross out the x's. X divided by x makes a 1. Can I cross out anything else? Nope. And then that means that this is our final answer. All right. Example 5. Okay, so step 1 is done. Step 2 is done. What about step 3? Yeah, the denominator definitely needs a negative to be taken out because the x had a negative with it. What about the top? Yeah, perfect squares, difference of squares. And what would that be? x plus 4, x minus 4. So we can say that x minus 4s cancel out. Those are exactly the same. So x plus 4 over negative 1, do we have to leave that like a fraction, or could we fix it?
Switch those signs.
Yeah, so x divided by negative 1 is negative x, positive 4 divided by negative 1 is negative 4. Yeah, so if you left it as a factored form, you could have left it like that. That would be fine as well. Yep. Okay. Example 6. Yeah, step 1 is done. It is written as a numerator over denominator. What about step 2? It is not in the right order. So we should have x squared, then what? Minus 4x minus 5. And we say these cancel. No, that would kill a puppy. Okay, so we can't kill that puppy. What should we do instead of killing the puppy? We should factor. So we are looking to see what multiplies to negative 5. No, that would kill a puppy. Why can't we cross this out? This is a minus problem, that's a minus problem, and minus and division don't cancel. All right, so we are multiplying to negative 5, but adding to negative 4. And what numbers do that? Negative 5 and 1. Okay, so we have x minus 5, x plus 1. And then on the bottom, we are multiplying to negative 15 and adding to negative 2. Negative 5 and 3. And the x minus 5s divide to make a 1. And it's okay if we cancel those because the top is multiplied and the bottom is multiplied. And multiplication and division actually do cancel. Yeah. Okay. Before you fall asleep, we have to add one more thing to our notes, and I'm going to have you guys maybe grab a marker or something. The markers are on the bookshelf. Sorry. Sorry, not sorry. No.
I'm sad.
You'll see in a second. All right. I'm going to go through here, and I'm going to tell you what the excluded values are. Excluded values. I'm going to go through and tell you what the excluded values are. I'm going to tell you what they are, and then we're going to see if we can figure out like why they're excluded, okay? So for example number 1, x cannot equal 0. I don't say it out loud yet. For example number 2, x cannot equal 0 or 2. For example number 3, x cannot equal negative 5 or negative 8. For example number 4, x cannot equal 0 or -1. For example number 5, x cannot equal +4. For example number 6, x cannot equal +5 or -3. Okay, did anyone figure it out? Yes.
Well, like for the first one, 0 can't be divided by anything. So, like if it equals 0, then it's times 3.
Yeah, so if you plug 0 in for x, you get 0 on the top of the fraction, which is okay, and then you get 0 on the bottom of a fraction, and can you do 0 divided by 0? No. Yes.
So all of these, and when you turn the equation into a standard form, if you plug in these numbers, you would have the denominator equal 0.
Yeah, so these are all the numbers that would make the bottom of the fraction equal 0. Yeah, Scott. So if you look at 5, it would make the left factor equal 0. So it doesn't matter if the factors cancel out or not. I don't care if they cancel. But when we look at the original factored form, it's anything that would make the bottom equal 0. Before we canceled and simplified. Okay, so if you look at this one, when it was first factored, it had 3 times x and then x minus 2. The 3 times x part is why you can't have 0. The x minus 2 part is why you can't have 2. For this one, if we look at it before we canceled it out, the x plus 5 part is why we can't have -5. The x plus 8 part is why we can't have -8. So the top of a fraction can equal 0. You can do 0 divided by 5, 0 divided by -100. You can do 0 divided by any number. But if you try to do a number divided by 0, it's not going to work, ever. Yeah. So if we look at this one, I'm ignoring these forms. I'm only looking at the factored form. The reason I can't have 0 is because this x right here. The reason I can't have -1 is because that parenthesis right there. Yeah. No, just undefined.
Okay.
So an imaginary number is only if you square root a negative. It doesn't mean, oh, it's something you're not allowed to do. It's like that specific situation. All right, for this one, we didn't look at the original form, although you could have. We looked at the factored form. The opposite of -4 is +4. That's why I can't have +4. And then the last one, can't have +5, can't have -3. Okay, so an excluded value in this unit is a number you are not allowed to plug in because it would make the bottom of the fraction equal 0. Okay, so we're going to go back and we're going to write this on your notes wherever you can fit it. We're going to say an excluded value is a value that makes the expression undefined. So in this unit, we would say the excluded value would make the bottom of the fraction equal 0. If we were talking about radicals, we might say an excluded value made the number underneath the square root negative. So we have different types of excluded values depending on the unit we're talking about, but for this unit specifically, we are making sure we don't divide by 0. So no 0 in the denominator. Okay? Make sense? Okay.